Okay, Assalamualaikum to all students. So now let's start to continue the examples of the first type, that is common emitter, amplifier with emitter grounded. Okay. So this is the example of the circuits with all the values given here. Beta is 100, your VBE is 0.7, and your early voltage is 100. So how are you going to solve this question? Okay, first step, you need to identify, is it common emitter, common base, or common collector. So how are you going to identify? You need to look at the location of your output. So if your V out is connected at your collector, so means this is common emitter. So in common emitter, we have three types, right? RE, E grounded, and CE. So look at your emitter. So this emitter grounded, So this is what we call type 1. Okay, now we are done with the first part. So next part. First of all, so what you need to do now, you need to find the value of all your currents. So you need to start with DC analysis. So what is the value of your IC, IB, and IE? Why you need this one? Because later you're going to find the small signal parameter where the formula will involve the value of your IC. So how are you going to change this one to DC equivalent? So keyword number 1, when DC equivalent, you need to make sure your capacitor is open or short. So in your DC equivalent, your capacitor need to be open. So what will happen when this capacitor will be open? Your AC source here will be isolated, right? And your VR also will be isolated. So let's redraw the DC equivalent circuit. So here you only have R1, R2, RC, and then you have a DC supply VCC, and then continue the rest. What will happen to your V out will be disconnected. Okay, so this is the voltage divider biasing. So what you need to do during DC analysis, you need to do what we call biasing. So what is the technique of biasing here? We call this one voltage divider biasing. So when we know this is voltage divider biasing, so you need to change this one to Thevenin, right? So we have here VTH, RTH, and you draw your BJT here, and here you have RC and VCC. So now before we start to do the loop equation, so there will be the BE loop and your CE loop. So before we start to do the loop equation, you need to know the value of your Thevenin. So how are you going to find your Thevenin here? So your VTH equal R2 or R1. So it's below, right? So become R2 divided by R1 plus R2 multiplied by VCC. How are you going to find your RTH? Is R1 parallel to R2. So in this question, it's already given all the value, right? So you just need to plug in all the values. So it means here 6.3K divided by the total of the R, 93.7K plus 6.3K, this is a point, multiplied by 12. And the same here, 6.3K parallel to 93.7K. And then once you calculate using your calculator, you can get the value of your VTH and RTH. Okay, so based on the equation just now, you can get the value of your RTH 5.9K and your VTH is 0.756. So now what's next? You need to find the value of your IC, right? So now in order for you to find the value of your IC, you need to find IB first. So what is the equation at your BE loop? So minus VTH plus RTH IB. Okay, what do we have between your B to E? Don't forget to add the VBE. VBE equal to 0. So by doing this, you can have your IB equal. So what is the VTH? 0.756. What is the value of VBE given here? Is the turn on voltage for your transistor, 0.7 divided by your RTH, that is 5.9K. So you can get your IB here, 9.49 microampere. So the key important point here, always leave your IB to microampere. Okay, so once you got your IB, now what you need to do now? Because what is the important value in order for you to proceed to the small signal parameter? You need to have the value of your IC. So how you calculate your IC? Equal beta IB. So you just multiply this IB to 100. So you can get your IC 0.949 milliampere. Okay, again, always leave your IB to microampere because IB is very small, right? And your IC always leave to milliampere. So now, do you need to find the value of IE? So it is optional. If the question didn't ask you to find the emitter current, so you can leave it, because what is the important point in order for you to proceed is the value of your IC. Okay class, so once you already find out your IC, so we are now in the third step. You need to find what we call small signal parameter, where we have R pi, R naught and GM. So based on the formula given here, so you're not going to memorize the formula. Okay, so how you're going to find the value of your R pi? So this is the formula will be given in the exam. So your R pi equal beta is 100, VT is 0.026 thermal voltage divided by your ICQ. So ICQ is 0.949 milliampere. So you can get your R pi. So how about R out? So if the early voltage here is given, so remember what is the early voltage in the not ideal condition. So your IV characteristic here will be there is a slope. So when you extrapolate the IV characteristic of your BJT, so this is IB1, this is IB2, right? Okay, so when you extrapolate, so this is what we call VA, early voltage. Okay, so in this question, the VA here is given. So if VA is given, so the R naught will be exist, so it become 100 divided by 0.949 milliampere. And the last one is GM. So now the last one is your GM. How you calculate your GM? So your GM is equal ICQ 949 milli divided by your thermal voltage 0.026. So okay, so once you calculate this one, then you can get the value as shown here. So R pi is in kilo ohm. Your R naught also need to be always in kilo ohm, and your GM need to be in microampere over V. So what is actually GM? Is the conductance. Conductance G equal I over V, right? I over V. So that's why the unit is milliampere over V. Okay, so now you have done the third step. So this until the small signal parameter. So what's next? So the next part you need to calculate the small signal voltage gain, right? When we have a small signal here, what will happen at your output? Is it will be amplified or not? So you need to change the circuit from the original circuit to what we call AC equivalent. So the work that you have done before is DC equivalent. Why you need to do DC equivalent? To find the value of your IC and follow to the small signal parameter. Now, in order for you to check whether it is amplified or not, you need to change to AC equivalent. So the keyword here, when you have an AC equivalent, your capacitor need to be shorted. Compared previously, DC equivalent, your capacitor will be open. Okay, so when you short the capacitor here, so your circuit will be, you're connecting to your input here. This is AC input. So here is your RS, and then your CC is connected, and you have here R1, R1, R2. Now, what will happen to your VCC? This is a DC supply. So, at your AC equivalent, your DC supply need to be shorted and connecting to ground. So, here you have RC, and it will be shorted and then connecting to ground. So, this is important. And then you will connect here to your ground. Where is the location of your Vout is at your collector. So now we have two ground, right? The above ground and the below ground. So next you need to change this circuit to combine the ground. So it will become, here is again VS, here is RS, and then here you have R1 parallel to R2, and then here you have your BCE. Now your C here, this locate here C. C is connecting to your RC and then move to ground. What will happen to your E? Also ground. So all this will be connected together. And where is your Vout? Is the most right. Your input is the most left. So this is what you want. Okay. Now what's next? You need to change your BJT. Remember the 3 terminal? So always start with this, what we call this 3 terminal. How you remember this one? BEC, and between here you have R pi, between C to E you have what we call GM VBE. Where is your VBE? Is here. And again, since this question is having VA and you calculate just now your R not here, so you have here your R not. Okay, the whole here represent your BJT. And how you're going to proceed, just continue the rest of the elements. So here at your base you have R1 parallel to R2, and here you have RS, and here is VS, and all this will be ground, right? And your emitter also will be grounded. And then after R out you have one element, extra element is RC, and here is your V out, here is your VS. Okay, so now let's derive again. First locate, this is your R out, and here is your R in. So this is your AC equivalent circuit. Now let's start to derive again. So as a revision from the previous video is the same. So you're going to start at output or input. So always start at your output. So output is V out equal I out Ohm's law, right? I out R out. So what is the current flowing from this output circuit? So this is your output circuit. So here is plus minus, right? So your current will flow from here, but your current source here is opposite direction. So your current will have minus here, minus GM VBE. Now what is your looking from here? This is your I. Looking from here, what is the value of your R out? So this one both are parallel. R out parallel to RC. Okay, so this is the derivation of your output. So now let's move to your input. So where is your input? Here, right? Number 2 is your input. So your R in equal, what is your input resistance? So you're looking from here, your input resistance is R1 parallel to R2, and it also parallel to R pi. Okay, so then you need to have this voltage divider circuit at your input. So let's draw it again. So here is your VS, here is your RS, and then the whole here become your R in. Now we want to know what is your VS here. The voltage here, it will not be the same at this point, right? Because you have RS. So you need to introduce another term here that we call V in. So how are you going to find V in here? By using voltage divider, your V in will be the resistor at the V in divided by the total resistor multiplied by Vs, right? Okay, this will be equation number 2. 1. Now so the final step is for you to find the derivation of the voltage gain. So what is voltage gain? Is the voltage output over this Vs, right? Over voltage at the input. So V out coming from number 1, Vs is equal V out multiplied by 1 over Vs. So what is 1 over Vs is equal 1 over V in R in divided by R in plus Rs. So V out, it come up from minus Gm, VBE, R out parallel to RC multiplied by 1 over V in, R in over R in plus Rs. So take note here, you have VBE and you have V in. So if you look at the circuit, where is your V in? So this point will be your V in. Where is your VBE here, right? So this is a parallel circuit. So you can equate your VBE is equal to V in. Your VBE is equal to V in. So you can cancel this one. So you can get your final equation for your gain is equal minus Gm R out parallel to RC multiplied by R in divided by R in plus Rs. Okay, so now you need to find R in. So what is R1? 93.7K parallel with, what is your R2? So this is capital R. 6.3K parallel to R pi. So your R pi you calculate previously, you can get 2.74K. So you can get the value of your R in. Okay, after you find R in, so now we can find the value of your gain. So what is Gm here? Gm is minus 36.5 milliampere over volt multiplied by R out. So R out, due to we have the VA here, so it's 105.37 kilo. This one you refer to this equation. Okay, so kilo parallel with RC. So the value of RC here is 6 kilo ohm. Now we multiply by your R in. So your R in here is 1.87 kilo ohm. So here is R in 1.87 kilo ohm divided by 1.87 kilo ohm plus 0.5 kilo ohm. Then you can get the value of your AV. So your value of the voltage gain is minus 163.5. So what does this value mean? If you can get your AV equal minus 163.5, your R in just now is equal to 1.87K. How you find your R out? So your R is R out parallel to RC. So please take note, R out here is not the same with capital R out. So capital R out is from where? When you look your eyes here, looking from here, what is the output resistance? But the R out, the small R out is inside your BJT. So how you going to find R out? So your R out just now is equal to 105.37 kilo ohm, and your RC is 6K. And you can get your R out. So your R out is 5.73 kilo ohm. Okay. So back to the voltage gain. So what does that mean by minus 163? Let's say you apply at the input here 1 millivolt. Wow, what will be the output shape? So AV is equal V out over V in. So here is your V in, here is your V out. So let's say how you're going to calculate V out is AV multiplied by V in. So let's say your gain here is minus 163.5, then you need to multiply by 1 millivolt. Okay, so if I change here is take 1 millivolt. So here we're going to have 1 volt. So your V in here is 1 volt. So how much is your output? Minus 163.5. So since it is negative, so your output is inverted and amplified. So what is the peak voltage here? Is minus 163.5. So that's how we derive the voltage gain. So what you need to do now, you need to at least derive first, and then you can get this long equation, and then you plug in all the numbers, and then you can get your voltage gain. Okay, so if you have any question, please let me know before we proceed to another type of common emitter amplifier. Okay, bye bye. Assalamualaikum.